Good evening, everyone.
Good evening, ma'am.
Good evening. How are you all?
Good evening, ma'am.
Fine, ma'am.
All good?
Yes, ma'am.
Okay. Okay. So today we have an open session for week 11. Have you guys gone through week 11?
Just half of it.
Just half of it. Okay. Okay. So let's do it then. Let's start with week 11. Okay. Okay. So those who have just read the week 11, can you tell me what is there in week 11? Any rough idea? What is it about?
Binomial distribution.
It is about distributions, yeah. So basically it is about discrete distributions. Okay. So in discrete distributions, we have four types of distributions. First is, sorry, three types of. First is binomial. Then second is Poisson. And third is hypergeometric. Okay. These are the three distributions that we will be learning in week 11. Okay. Now let's start with binomial thing. Okay. So before that binomial, can you tell me what is a Bernoulli trial?
Which has only two outcomes, 0 and 1.
Which has only two outcomes, which is 0 and 1. So basically, my
No,
Bernoulli
outcome
trial,
of failure and a success.
yeah, correct. So basically, my Bernoulli trial are that trial in which there are two outcomes. Okay, the first one is a success, and the second is the failure. If I have two outcomes, then I say that it's a Bernoulli trial. Okay, so let's suppose if my x is a random variable which is taking values 1 and 0. 1 is for the success and 0 for the failure. Then I say that my x is a Bernoulli random variable, correct?
Random variable.
Yeah, okay. Okay, now if my x is a random variable which is taking 1 and 0 values, so so what will be my PMF? If my x is taking values 1 and 0, what will be my PMF?
P and
For
1
1,
minus
it will be
P.
P, and for
1
0, it
by
will be
2.
1
1
minus
minus P.
P. So this is my PMF of a Bernoulli random variable. Okay. And what is the value of expectation? Expectation will be, what is the formula of
P.
expectation?
P.
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 Okay. Also, it will be 1 into P plus 0 into 1 minus P, correct? This is how I solve the expectation. So this will be 0 into 1 minus P is 0 and 1 into P is P. So the expectation of a Bernoulli random variable is P, correct? Similarly, what will be my variance? Variance is expectation of x square minus expectation of x whole square. So
P into 1
first you
minus
will solve this thing. Expectation of x square is basically what? 1 square into p plus 0 square into 1 minus p. So this is p only, and so just put the values here. So variance of x will be p minus p square, which will be p into 1 minus p, or you can write it as p into q, where q is my,
failure.
sorry,
Probability of failure. PMF of 0.
mm, you can say that. So q is basically my, q is equals to 1 minus p. Okay, so this is a Bernoulli. So what is a Bernoulli trial? Bernoulli trials are the trials in which I have two outcomes, which is a success and a failure. Okay, and the PMF is given by the probability that success occurs is P, and probability that zero occurs is 1 minus P. So if I find out the expectation will be the P, and variance will be P into Q, or you can say P into 1 minus P. Fine. Is this thing clear? Okay. Is this thing clear to everyone?
Yes, ma'am.
Yes, ma'am.
Yeah. Okay. Let me ask you one thing. When will be my variance maximum? At what value of p my variance will be maximum?
X square
And
0.
P equal to half.
1.5.
M at P equal
Sorry,
to half.
it will be p equals to half. Okay, can you just give me an example or can you just describe me why? Anyone?
And when it is equally likely,
Formula
like you
for
can get anything.
variance is a parabola. So at the vertex, you'll have maximum.
Just okay. So variance is basically we are actually trying to find out the variability, right? So if my p is 1/2, what do you mean by p? That the probability of success is 1/2, correct? P is my probability of success. So let's suppose if I'm tossing a coin, okay, if I'm tossing a coin, I have two outcomes, which is head and tail. So my success is getting a head. So now here comes that it is saying that the probability p, that is the probability of success, is 1/2. So it is saying that my probability of failure is also 1/2. That there is 50-50 chance that I can get a head, I can get a tail. So I am not sure whether like what is the like if I'm having a probability which is the like probability of success is a little bit higher than the probability of failure, then like I can say with a certainty that it will be a like the variability is less, right? Variability in the sense like I don't have that, like I cannot say in that certainty that the probability of like getting ahead will be more than the tails. Okay, so that's why p equals to 1/2. My value of variance is highest. Fine. Is it clear,
Yes, ma'am.
everyone?
Yes, ma'am.
Yeah. Okay,
Yes, ma'am.
so this is about Bernoulli trial. Now, as we were talking about the binomial thing, so let's suppose this Bernoulli trial is like only one experiment, right? Now, if I do this experiment like x1, x2, x3, x4, so these all are my IID experiments. Okay, do you know what's the full form of IID? Anyone?
No, ma'am.
Okay, so IID is basically independent and identically distributed. Okay, this should be not the experiment, but Bernoulli trials. Okay, so IID is basically my independent and identically distributed. Okay, so what is independent and identically distributed? The anyone from the words, can you just tell me anything? Independent and identically distributed.
It's independent in the sense is it is not dependent on the other outcomes.
Ah,
And
okay.
identically means, I think, equally likely distributed.
Equally likely distributed. Yeah, correct. Okay, so let's take an example. I am tossing a coin. Okay, I'm tossing a coin. So this is my first. So this is my first experiment. Okay, this is the first trial. So I'm having two outcomes, head and tail, which is the probability of getting a head is 1/2 and probability of getting a tail is 1/2. Similarly, second time I'm also tossing a coin, same thing, 1/2, 1/2. Third time also head, tail, 1/2, 1/2. Okay, so this is from the first toss, second toss, third toss. So similarly, I can get like, let's suppose I have done 10 tosses, head, tail, 1/2 and 1/2. Okay, so in an experiment, so I had like 10 tosses, and each of the 10 tosses, you can see I have like two outcomes, which is head and tail, right? So, and in each of the tosses, the probability distribution is same. Yes or no?
Yeah.
Yes, ma'am.
Yes. In this also,
Yes,
my
ma'am.
x is taking two values, right? 1 and 0, and the probabilities are also 1 by 2 and 1 by 2. Similarly, for this 1, 0, probability is 1 by 2, 1 by 2. So for all of these things, my probability distribution is same, right? So that's why this is identically distributed. Okay. What is identically distributed? In which my probability distribution is same for all of the tosses. Okay. And that is identically distributed. Now, what do you mean by independency? Independency in the sense, if I'm tossing in the first toss, I'm tossing the coin firstly. Okay. So now when I'm tossing a coin the second time, the outcomes that I'm receiving is not is it dependent upon the first toss? Is it?
No,
No,
ma'am.
ma'am.
Yes or no? If I'm
No,
tossing
ma'am.
No,
no,
ma'am.
No.
The outcomes are independent.
the outcomes are independent, right? So because the outcome that I receive in the second toss is, I'm like, it is not dependent on the first, right? So in the first toss, if I get head, also in the second toss, if I get tail, this the second toss that I am tossing, it's not dependent upon the first toss, correct? So that's why this is an independent and identically distributed. Okay, so I can say that. So now you got it. What is an independent and identically distributed Bernoulli trials? See, we are talking about IID Bernoulli trials. It should be a Bernoulli trials and it should be independent and identically distributed. So if you see here, the first experiment, it's a Bernoulli trial. We have two outcomes, H and T, right?
Right.
And we have the probability, PMF as well. And these
Can
are
you
IID
explain
also. So
the PMF? Can you explain the PMF once again?
PMF of which one? This one or
Yeah.
the example one? The
Ma'am,
example.
anyone.
PMF is like just the probability mass functions, right? So probability mass function in the sense, if my x is taking two values, 1 and 0, so each of these values is having some probability, right? This 1 is
Yeah.
having some probability and the 0 is also having probability. So what is the probability of occurring x is equals to 1 is 1 by 2. Similarly,
One
that
by
if
two. Yeah.
the value of x is 0 is 1 by 2. So that is probability mass function for each. So probability mass function is basically what? For the discrete values, right? We use PMF for the
Yeah.
discrete random. Yeah. So if my x is a discrete random variable which is taking 1 and 0, the probability of 1 is 1 by 2 and probability of 0 is 1 by 2. Okay, that is my probability mass function. Okay.
Uh,
Okay, got it, ma'am.
So what
if
I
I
was saying that, so we are considering a situation in which I have IID Bernoulli trials. In the sense, it should be independent and identically distributed Bernoulli trial. So if you see here, the first toss is a Bernoulli trial, the second toss is a Bernoulli trial, the third toss is a Bernoulli trial, and they are all identical and they are all independent. So this is my IID Bernoulli trial. Is the definition clear?
Ma'am, if the Bernoulli trials are independent, then is it sure that it will be identically distributed also?
If the
Independent and identical, I'm getting confused over it.
See, independent is a different term and identically distributed is a different term. Identically distributed in the sense, in each of these cases, my probability mass function is, the probabilities are same, right? The occurrence of head is 1 by 2, the occurrence of tail is also 1 by 2. In the second toss also, my occurrence of head is 1 by 2, my occurrence of tail is also 1 by 2. Right? So the probabilities are same in each of the tosses, in each of the trials.
Ma'am, what is
Okay.
the
So
difference between them? Actually, I understood the independent distribution, but
what do you
identically,
understand by the independency?
if head occurs, then if the first trial occurs, then uh, it won't disturb the second trial.
Yeah, correct. Okay. Then what do you understand by the in identically distributed?
Actually, that is what where I'm getting confused.
Okay, see. Okay. Did you understand this example that I just explained it to you?
Yes, ma'am. And what if the head, if the biased point is there, then can you explain that
So
example?
then that is not identically distributed, right? So we are just taking independent. If I'm okay, the main thing is these are all trials. Okay. This is one experiment which is tossing a coin. So I'm in the tossing of coin, I'm having 10 trials. In the first trial, I'm having two outcomes, head and tail. Whose the probability is 1 by 2 and 1 by 2. So this is my first experiment, right? For this first experiment, this is my probability mass function, correct?
Okay, ma'am.
Yes. Okay.
For
So
in identical, does it mean that uniformly distributed?
identical, no. Identical in the sense or you can say the variance or the mean or anything, the values, right? These are the probabilities are same for each of these trials. That is identically distributed. Identical, just look at the word identical. They should be identical to each other. The probability should be same, or the mean should be same, the variance should be same PMF, same PDF, same mean, same variance. If I'm having in each of the trials, if you see here, my probability mass function for each of the trials are same, right?
Okay, so properties should be same
Ha,
for every
ha,
trial.
correct. So that's why. So this tossing a coin is a basically my independent and identically distributed Bernoulli trials. Okay.
Ma'am, I have a question.
Hmm.
Can we have any Bernoulli trials which are not IIDs? Like any
We can
example?
have. Yeah, we can have. If we are like, let's suppose if we are having an let's suppose, okay, in a bin there are like in a bin there are like 10 balls. Okay, so now like we are just taking out one ball at a time. Okay, and the thing is, the ball, if you're taking it out, you are not keeping it back in that bin, right? So basically it is an experiment without replacement, right?
Yes, ma'am.
Yes,
Yes. Without replacement, do you understand what is the difference between with replacement and without replacement?
Yes, ma'am.
Right. So there is a bin. Okay. There are 20 balls here. Let's suppose 20 balls. Okay. I am taking out one ball. Okay. And and just counting it. Okay. So after taking out one ball, how many balls are left? 19.
Yes, ma'am.
Again, I'm taking out one ball. Then again, 18 balls. Yes. So
Yes,
in
ma'am.
such a way, the balls are getting reduced. So this is a case of without replacement.
Yes, ma'am. But how this
Okay.
will be a Bernoulli trial?
No, I'm just give. Okay, I'm not taken the Bernoulli example.
Okay,
I'm just
okay,
telling
okay,
you. If I'm
okay,
having
ma'am.
an
This
experiment in which there is a without replacement thing.
okay.
So
Yeah,
if
that
there is a
is.
so if I'm having an experiment which is a without replacement, the probabilities in each of the trials will be different.
Yes, ma'am.
Yeah. So in
Okay.
that case, that won't be my independent and identically distributed Bernoulli trials. Okay.
But that's what my question is, ma'am. Like, how it is a Bernoulli trial? This experiment, is it a Bernoulli trial?
Which one? This one.
Yeah, the recent one
Okay.
with
Let
us.
me take a Bernoulli trial example only. Let's say. Okay. Let's suppose there are uh, two types of balls, red and white color balls in a bin. Okay. So there are 10 red balls and there are 20 white balls. Okay. Now the thing is, the experiment is you are you are taking out three balls at a time. Okay. Three balls at a time. Now you are checking the number of red balls that you have got. Okay. That is my experiment. The number of red balls that you are taking out. Okay. So now it's a case of without replacement. Because if you're taking out three balls, then you're not keeping the three balls in the bin again. In total, how many balls do I have? 30, right?
Yes, ma'am.
Okay. So I'm taking from the 30, I'm taking out three balls. Okay. Now I have to count the number of red balls that I have taken out. right? So in each of the time, if I'm taking out 3 balls in each of the time, my and it is a case of without replacement also. So if I'm taking out the balls, then in the next trial also, if I'm taking out the balls, if 3 balls is reduced from 27, I have to take out 3 balls, right?
Yes, ma'am.
Yeah. So in that case, in this case only, I can say that it's a non-independent, right?
Yes, ma'am.
It's not independent because my second trial is dependent on the first trial.
Yes, ma'am.
Yeah. Okay. And in the second trial, you see my in the first trial, my the probabilities are different, and in the second trial also my probabilities are different. Correct?
Yes, ma'am.
Yeah. So this is a case of non which in which I don't have IIT Bernoulli trial. Okay.
Okay.
Yeah.
Thank you,
That's it.
ma'am. Yeah.
Okay. So this what I was saying. Yeah. So I was saying about the binomial. So so you guys understood what is an IIT Bernoulli trial?
Yeah, ma'am.
Okay. So now let's generalize it. So my binomial is basically we have n independent trials. Okay, we have n independent trials in which I'm having two outcomes, which is a success and a failure with probability p and 1 minus p. Then x is the total number of success in n that occurs in n trials. Then I say that my x is a binomial with parameters n comma p. Okay, so this is how I denote a random variable with a distribution. So I say that my is following a distribution, binomial distribution with parameter n and p. Okay, so what is a binomial? So if I'm having n independent Bernoulli trials. Okay, so these are my Bernoulli trials, right? Because I'm having two outcomes, success and failure with probabilities p and 1 minus p. So if I'm denoting x, a random variable, as the total number of success in that n trials, then I say that my x is following a binomial distribution with parameters n and p. Is this clear?
Yeah, clear, ma'am.
Okay, so the main thing is, if you want to see whether my experiment is a binomial, the main thing is my n should be fixed. What is n?
Trials.
The n is the number of
Number of
trials.
trials.
Okay, so if I'm saying that I'm tossing a coin 6 times, so x is so basically, let's suppose I'm taking an example, I'm tossing a coin 6 times, and I have to check the number of heads that I get. So my number of success, my what is my success thing? The getting a number of heads, correct? Yes.
Yeah.
Yeah. So
Yes,
can I
ma'am.
say that this experiment is a binomial experiment?
Yeah, it is binomial.
Yeah,
Yes,
because my
ma'am. It
n
is
is
binomial.
fixed, right? So, okay, let's take one other example. Let's suppose there is an experiment in which I am rolling a dice, okay, and x is a x is a random variable which is denoting the number of the like number of times six appears. Okay, that is my experiment. So, can you tell me whether this is a binomial experiment or not?
No, it is not binomial
Why?
experiment because like we do not have only two choices. It contains six sites, so we have six choices.
Uh, okay, so basically that I told you. See, my experiment was that I am rolling a dice. Okay, I'm rolling a dice such that I'm rolling a dice, and my x is a random variable which is denoting that how many times my six appears. But in that experiment, I am not saying how many times I am rolling a dice. Correct? I can roll a dice 1 time. I can roll a dice 2 times. I can roll a dice 3 times. Correct?
Yes, ma'am.
Yeah. So I'm not fixing the number of trials. So that is not my binomial experiment. You got the difference?
Yes, ma'am.
Yeah.
Yes, ma'am.
Sure.
Yes, ma'am.
Yeah, got it, ma'am.
Got
Yeah.
it? Yeah. Okay. Just a second. Just give me a moment. Mm, mm, mm. Okay. Now, so let's take Okay, so this is my definition of a binomial distribution. And what is the PMF of a binomial distribution? It is basically denoted as probability of x equals to I is NCI p raised to the power I 1 minus p raised to the power n minus I. Okay, so this is my PMF of a binomial distribution.
Ma'am,
Okay.
what is I in this case?
Huh?
What is I?
I is the like, see, if my, okay, let's take an example. Just give me a moment. I'll just search it in any activity if I get one example.
This is a particular instance, right? In the
Yeah, at a particular instance. Let's suppose if my x is, mm, let's take an example. Like I am tossing a coin 3 times. Okay, this is my n. N is 3 here. Okay, and my x is basically getting ahead. Okay, this is my success, right? So what is the probability that x equals to 1? What do you mean by x equals to 1?
That we get one head.
One head.
First,
So this is basically my I. So this is, I can write it as 3CI. I is basically 1. So just replace I with 1. P is the probability of success. So for one trial, if I toss in a coin, I'm having two outcomes, H and T, right? So getting a head is 1 by 2 and getting a tail is 1 by 2. So can I write the probability P is 1 by 2?
Yeah.
Yeah.
yeah,
So
ma'am.
this will be 1 by 2 raised to the power 1, 1 minus 1 by 2 raised to the power 3 minus 1. Fine.
yes,
Fine.
Okay.
So I is the number of success.
I is the number, like the number of success. You can say that. Yeah.
it's the total.
Okay.
It's the values that X can take, not the number of success. I would say.
Yeah, I think it is, ma'am. If x is equal to 0, then I would be 0, right? So the
Yeah.
number of probability of a random variable.
Basically, x is the I is basically the numbers. So if my x is one, one in the sense that I got only one time head. If x is two means I'm getting two times head. I'm just denoting it with a number. So what is the probability of getting two times head? What is the probability of getting three times head? That is my I. I'm just okay. So my okay. If I'm tossing a coin 3 times, what all values that x can take? X can take 0, 1, 2, and 3. Correct.
Yes.
Yes,
So
ma'am.
this is my
Yeah,
I. These
ma'am.
are the values that x can take, right? And we will count the probabilities. How will you count the probabilities? In this way. Got the point?
Yeah,
Yes,
ma'am. Got
ma'am.
it.
Yes.
Yeah. So I is the number of values which can be stored. Like this, in this case, we are tossing the coin 3 times, so it can take up to three, like
Ha.
0, 1, 2, 3.
Two,
Yeah,
three.
that is
Ha.
correct.
Hmm. Okay. So can you just tell me what is the probability of x equals to 1 if you just count this value? This is 3C1 is basically 3
We
into
get 3
1
by
by
8 as the
2 into
answer.
1 by 2. 3 by 8 as the answer. Can you guys tell me what is the probability of x equals to 0, 2, and 3? These values.
For 0, it is 1 upon
Uh,
8.
One
0
plus.
is 1.
yeah,
No, one,
1
yeah.
one by
upon
So
8.
0 is
1/8.
Yeah.
1 upon 8.
1
For
1
2,
upon
it
upon
8.
is
8.
1 upon 8. And for 3, it is 1 upon 8. Sorry, for 2 is 3 upon 8.
3 upon 8 and this is 1 upon 8.
1
Yeah.
upon 8.
Sure? Are you all sure? Is this the correct one?
Yes, ma'am.
Yes.
Yeah? Okay. So, so you guys got to know how to calculate the PMF? Yes or no?
Yeah, ma'am.
Yeah?
Yeah, ma'am.
Everyone?
Yes,
Yeah?
ma'am.
Yes,
No
ma'am.
doubts. Right?
Ma'am.
Okay. Now there is one more thing. Okay. So we have got this, the PMF, right? Now we can make a graph also, right? So there is one thing, shape of the PMF for same N but different P. Okay. There is one thing. The first thing is if I'm having P less than 0.5. Okay. then the graph will be a right skewed. Okay. And if my P is greater than 0.5, the graph will be left skewed. Okay, just a second, just hold a second. Okay. So if my P is less than 0.5, I say the graph is right skewed. If my P is greater than 0.5, it is left skewed. And if my P is equal to 0.5, it is said to be symmetric. Okay. So in such way, okay, let's suppose if my N is 4 and my P is 0.3. Okay. So if like I will be calculating some values, I will be having some PMF. Okay, I'm just writing, like I'm just drawing the graph. Okay, so my graph will be looking like this. Okay, so this is my right skewed graph, correct? Because
Yeah,
it
correct.
is in the shape of like this. My right
Yes,
skewed
ma'am.
is basically in this shape, correct?
Yeah,
Now,
ma'am.
if I take same, N is 4 and my P is basically, let's suppose 0.8. Okay, now my graph will look like this. Okay, so if you see here, my values are like, this is like
Left
left
skewed.
skewed, right? So this is my left skewed. Okay, now if my N is 0, sorry, N is 4 and P is 0.5, then my values will be, my graph will look like
Symmetric.
symmetric. Okay,
Symmetric.
so this is a symmetric graph. Okay, so this is the thing. So if my N is same and my P is different, so if my P value is less than 0.5, the graph will look like a little right skewed. If my P is greater than 0, so this is greater than 0.5, this is less than 0.5. If it's greater than 0.5, it is left skewed. If it is equal to 0.5, it is symmetric. Correct?
Ma'am, I have little confusion.
Uh,
Yeah, in the value of x you were described earlier, like how we got 3.8 and yeah, 3
3.8.
upon 1, sorry, 3 upon 8 and
Uh-huh.
in the, yeah, in the 1, 2, 3. That. Is it like putting the value in the formula you have given for
Just
PMF?
we have put the values. If you see here, probability of x equals to 1. 3 see, if you see the formula, in place of n, I have 3, correct?
Yeah, okay. Then
Hmm?
it's fine.
Yeah,
Then
just put the values in the formula and you will get the answer. Okay.
okay.
Yeah. Okay. So this is the graph. Now, if the main thing is, if I increase the value of n, let's suppose if my n is 40 and my p is like 0.3 for the same thing only. If I increase this thing, my graph will look little symmetric like this. Okay, so this is my graph. If I increase the n, my p is same, but I have increased n, right? So it will be symmetric. Understood? So there is one thing. If my value of n is same for all the values of p, and if my p is less than 0.5, it is right skewed. P is greater than 0.5, left skewed, is equals to 0.5, symmetric. And if I increase the value of n, the binomial distribution reaches to symmetricity. Is this thing clear to everyone?
Yes, ma'am.
Yes, ma'am.
Yes? Okay.
Yeah, ma'am.
Okay. Now, next thing is we have the expectation and the variance.
Ma'am, one thing, when
Hmm.
you are increasing the value of n, you are increasing the number of experiments.
Uh,
Like in that at that point of time, is it fully symmetric or is it a little at least skews, left skewed or right skewed?
No, if we are increasing the symmetricity, my variance will be less. Alright, so that's why it converts into a symmetric distribution. So if I increase the value of n and many times, then it will tend to symmetricity. That's it.
Okay, got it.
Ma'am, it
Okay.
starts converging towards that 0.5 value, right?
Sorry, once again.
Because this is a Bernoulli trial, right? At the end of the day, so there are like a half 0.5 is the value, right? So for
Hmm.
higher experiments, it would converge towards that 0.5 value. I guess
Hmm.
that's the reason is it is symmetric, like kind of symmetric we get at the higher trials.
Because of p equals to 0.5, you're saying that?
Yeah, because in Bernoulli trial we have this two values, right? So what happens in the larger experiment or trial? What happens? It converges towards that half value, right? 0.5 value.
Correct.
That's the reason. Okay, okay.
In the sense, if you just my n is like getting larger and larger. So if you calculate the probabilities, right, the probability of success will be same only. So for all the values of for all the in all the trials, my probability of p is same. But if you increase the n, the values of the probabilities will be um,
So it starts converging towards that 0.5 mid value.
towards, like, it will be symmetric. Like the probability of x equals to 0 would be equal to the probability that my x is um in the sense like the last like 40 or 50 or something kind of like that. So it will like the values will be same for all the extreme values. That's why it will be a symmetric distribution. Okay. Okay. We have now expectation and variance. Okay. So for expectation and variance, so we have, if I'm saying that my x is a binomial distribution with n comma p, right? So I can write x as x1 plus x2 plus x3 plus x4 plus like so on xn, right? X1 is the success of the first trial. X2 is the success of the second trial. X3 is the success of the third trial. Basically, what is my x as a binomial distribution? It is the total number of success in a Bernoulli trials, yes or no?
Yes, ma'am.
Right? So
Yes,
can I
ma'am.
write x as x1 plus x2 plus x3? Yes or no?
Yes, ma'am.
Yeah. Now, if I
Yes,
have to calculate the expectation of x, this will be what? Expectation of x1 plus x2 till xn. Yes.
yes,
So this will be expectation of x1 plus expectation of x2 plus expectation of xn, right? Now, for each of the trials, what is my expectation? It is p only.
yes,
This also p till n p. So can I write it as np?
yes.
Yes,
So
ma'am.
my expectation of a binomial, sorry. So can you mute yourself?
ऐसे ही रखा जाता है।
Sona, Sonali? Yeah, thank you. Okay, so this is my expectation of a binomial distribution, which is n into p. Now, similarly, can I calculate the variance? Variance will be variance of x1 plus variance of x2 plus variance of xn. Can I write it like this?
Yes, independently. I'm sorry.
Because they are
Yes,
independent,
ma'am.
correct. And variance for each of the trial is like PQ plus PQ till n time. So can I write it as NPQ,
Yes, ma'am.
right? So this is my expectation and variance of a binomial distribution. Is this thing clear?
Yes, ma'am.
Yes? Okay. Let's solve one question. Give me a minute. Okay. So there is one question from activity 11.5, question number 1. Okay. So they are saying that x is a binomial random variable with mean 5.4 and n is 9. Can you tell me what is the value of variance? See, if x is a binomial, I have to write it in this way, n in n comma p. Yes.
Yes, ma'am.
Now, n is the number of trials. In the question, it is given to be 9, and we don't have this value, correct? So we have to calculate this value, which is p. And we have the value of mean. Can you tell me what is the formula for a mean of a binomial distribution?
Will be expectation by n, right?
Sorry?
Or we can calculate yes by expect that mean
Expectation
n.
by n.
No, I'm just asking what is the expectation
It is
of a
xi
binomial.
into p.
Summation of xi into pi.
Uh, no, for a binomial,
P.
n into p.
Yes.
Okay. Now, so according to the question, this n into p is basically 5.4, right? I have the value of n, which is 9 into p equals to 5.4. So this p will be equal to what?
0.6.
0.6. Okay, so I've got the value of p. So can I write x is a binomial with 9 comma 0.6 as a parameters? Now what will be my variance? Variance, the formula of variance is
PQ.
NPQ.
NPQ. So this will be 9 into P is 0.6 into Q is 0.4. Can you calculate this value and tell me the answer?
Ma'am, how it is Q become 0.4?
What
2.16.
is my Q? Q is basically 1 minus P.
Oh, okay, ma'am. Yeah, got
1
it.
minus 0.6, 0.4. Can you tell me this answer?
2.16.
2.16.
2.1.
2.16.
2.16.
This is my variance. Is the question clear?
Yes, ma'am.
Okay, I'm giving you one other question. Do you guys have pen and paper with you?
Yes.
Okay,
Yeah, ma'am.
this is next question. X is a binomial, okay, with parameters n comma p. You have the value of expectation, which is 6. You have the values of variance, which is 3.6. Can you tell me the values of n and p? Solve it and tell me the answer.
N is 15 and P is 0.4.
0.4.
0.4.
N is 15 and p is 0.4. Everybody agrees with it?
Yes.
Yes, ma'am.
Any other answers? Any other different answers anyone is getting? No?
No, ma'am, same answer.
Same answer? Okay. Okay, let's solve this then. Let's see. So my expectation is 6. That means my NP is 6 and my NPQ is basically 3.6, right? So my NP is 6. I can write the value in place of NP. I can write 6 into Q equals to 3.6. My Q will be 3.6 divided by 6, which is 0.6, correct? So if I have the value of Q, my P will be 0.4. Yes?
Yes, ma'am.
If I have the value of P, so just put the value of P here. So N into 0.4 equals to 6. N will be 6 divided by 0.4, which will be N is equals to 15. So
Yes.
I've
Yes,
got
ma'am.
the value. So I can say my X is a binomial with parameters 15 comma 0.4. Is the question clear to everyone?
Yes, ma'am.
Okay. Now you have calculated
Yeah.
this. Can you calculate the probability of X equals to 3?
If n is given to us,
What? What is it?
I'm saying if n is given to us.
We calculated, right?
Okay.
0.0633.
0.0633. Okay, what about others? Any other answers?
0.0633.
0.0633. Other than this?
0.633.
0.633 or 0.633.
518. That
Sorry?
is 0.51 is something unlimited.
0.518, right?
Yeah.
Any other answers? Anybody else solving this question?
Ma'am, 0.06338.
Mm-hmm. ठीक है. Anybody else solving this question? Shall we solve now? Shall I solve now? Let's see the answer.
Yes,
So,
ma'am.
we know the general formula. Probability of x equals to y is basically what? N
N is 15.
into what is my p? 0 to the power 3 into 0.4 raised to the power 15 minus 3. Correct? So what is 15c3? 15 factorial divided by 3 factorial into 12 factorial into 0.4 cube into 0. Oh, this will be 0.6. 0.6 raised to the power 12. Right? So now after solving this, you will be getting value. You will be getting 0.063. So this is my answer. Is the question clear?
Yes, ma'am.
Yeah, ma'am.
Yes, ma'am.
Yes. So this was all about the binomial distribution. Is the binomial distribution clear to everyone?
Yes, ma'am.
Yeah, ma'am.
Yeah? Okay.
Yes, ma'am.
Okay. Let's
Can you
go
give
to
one more question?
one more question. Should I give?
Yeah, ma'am.
Okay. Okay. Let's see. Mm, mm, mm. Okay. Let's solve one question. Okay. This one is okay. I'll write down the question. In a 4-match test series, between India and Australia. What is the probability that an Indian captain will win at least two tosses? Okay, and they are saying that both the captains have equal chance of winning the toss. Okay, so this is my question. So we have four match test series between India and Australia. So we have to calculate the probability that an Indian captain will win at least two tosses. And the condition is both the captains have an equal chance of winning the toss. Okay, so this is my question. And now you tell me the answer. Take your time and tell me the answer. Is the question clear to everyone?
Yes, ma'am.
Yes. Okay.
Is it one by? Sorry, it's three
Sorry.
by
0.75.
0.6875.
3/4.75.
3/4. 0.75. 3/4.
Ma'am, 0.75.
0.75. Okay. Any
Yeah.
other answers?
Ma'am, 0.6875.
Ma'am,
Point.
0.6875.
Okay. Then any other answers? That's it. Only two answers I got. Okay. Let's solve this question. Anybody solving this question right now? Still solving it?
Ma'am,
Should I
11
wait?
by 16.
11/16,
Yeah, ma'am.
which is equal to 0.85, right? Okay. Any other answers?
0.875. No, no, no.
0.875. Okay.
0.6875.
0.6875. Okay. Any other? That's it? Okay. Shall I solve it or should I wait for a few more minutes for those who are yet solving it?
Ma'am, 11 by 16 is 0.6875, not 0.85 that
Oh,
you have
sorry,
written.
sorry.
Yeah,
0.685. Correct, correct. Okay, okay. Yeah,
okay.
I mistakenly wrote 13. Yeah.
Actually, ma'am, I solved it just now. Na, that's why I did not like convert it into decimal. That's why I told you directly
It's
the
fine, it's fine.
fraction.
Okay. So should I solve it or anyone solving it right now? Still solving it? Should I solve?
Yes, ma'am.
Yeah? Okay. So in a four-match test series, that means the number of matches are four between India and Australia. What is the probability that an Indian captain will win at least two tosses, right? So X is basically winning the number of tosses, right? So my success is number of tosses. Fine. Okay. So if there are four matches, X can take values how many? 0, 1, 2, 3, and 4. Correct? Yes?
Yeah, ma'am.
Okay. Now they are asking will win at least two tosses. That means the probability that my X is greater than equal to 2. Yes?
Yeah,
Now,
ma'am.
can I write this as the probability that 1 minus probability that X is less than 2?
Yeah, ma'am.
Yes,
So
ma'am.
this is basically 1 minus probability that X equals to 0 plus probability that X equals to 1. So now
Yes.
this will be what? So probability x equals to 0 is basically what? 4C0. What is my P here? Probability of success?
Ma'am, 1/2.
1 by 2. So this is 1 by 2
Yeah,
raised to the
0.5.
power 0, 1 by 2 raised to the power 4. So this is basically 4, 1 by 2, 1 by 2 raised to the power 4. Now probability x equals to 1 will be 4C1, 1 by 2 raised to the power 1, 1 by 2 raised to the power 3. So this is 4 into 1 by 2 into 1 by 8. Okay, so this is 2, 4. So this is 1 by 4. So now, probability that x is greater than equal to 2 will be 1 minus 1 by 16 minus 1 by 4. So if you solve this, 1 minus,
Plus
hmm?
plus 16, 1 by 16 plus 1 by 4.
Oh, sorry. So this will be 1 plus 4 by 16, which is 1 minus 5 by 16. So if you solve this, this is 11 by 16. Correct. So my answer is 11 by 16. Probability that x is greater than equal to 2 is 11 by 16. Is the question clear to everyone?
Yeah, ma'am.
Yes, ma'am.
Yes?
Ma'am.
Okay. So can I so this binomial thing, I guess, I hope everyone understood, right?
Yes, ma'am.
Yeah,
Yeah?
ma'am.
Oh.
Yes, ma'am.
So what is the condition for a binomial experiment? Can you guys tell me?
I
It should be a Bernoulli trial.
Hmm?
Ma'am, n number of repetitions of a Bernoulli trial.
N
I
number of repetition of a Bernoulli. And it
And
should be,
n should be fixed.
N should be fixed. And if there are trials, it should be which trials?
Bernoulli.
Bernoulli trials.
No, no. If I'm having Bernoulli trials, what type of Bernoulli trials I'm expecting?
IID. IIDs.
Correct.
IIT.
IID
IIT.
Bernoulli trials. Yes. Okay, so this binomial thing is clear. So let's jump into the other distribution, which is a hypergeometric distribution. Okay, so if you see in binomial thing, we had the case that it should be an independent, right? So now there are many cases in which the cases in which the experiments are not independent. Okay, at that moment we consider it as a hypergeometric distribution. Okay, let's take that example only in which I took this example, right? The ball one, 20 balls, and this one. Where is it? This one example. Let's take this example. This was the example in which I have a without replacement case, correct?
Yeah, ma'am, correct.
Yeah.
Yes,
So let's
ma'am.
suppose, let's take it this example only. So in a box, I am having four white balls and three blue balls. Okay. Now I am taking out, give me a moment. Just hold for a second. Okay. Where was I? Okay. Hypergeometric distribution. Okay. So in hypergeometric distribution, it is that case in which my experiments are not independent of each other. They are dependent on each other, not independent. Okay, this is the case. So we were taking one example in which I have a bin in which I have four white balls and three black balls. Okay, so condition taking out two balls from this. Okay, without replacement. This is my thing. Okay, so if I'm taking out two balls, so with two balls, it should be, if I'm taking out two balls, it should be without replacement. So if I'm taking one ball and after that again I'm taking the another ball, it should be without replacement. Okay, I'm not cases, right? In the first trial, I can have black ball and a white ball, correct? Yes or no?
Yeah, ma'am.
Yeah.
Yeah, ma'am.
Now, if I take, so this is my experiment in which the in the first trial, in the first, if I'm
Ma'am,
taking out
can
one
you
ball,
repeat it once because you were not audible earlier?
I was not audible. Okay,
Uh,
from starting.
no. This is hypergeometric testing.
Your voice was coming late, ma'am, actually, that time.
Any network issue, maybe. Now is it fine? If this is this fine now?
Yes,
Is it
ma'am, now
coming?
It's
your audio is
fine.
fine.
Now it's fine. Okay. Okay. So hypergeometric is the case in which I'm having not independent trials. Okay. So if I'm having a box in a bin, I have four white balls and three black balls. Okay. I'm taking the condition is that I'm taking out two balls without replacement. Okay, that means if I'm taking one ball out, and after that, when I'm taking out the second ball, that one ball that I've taken out, I have not put it back. Okay, so this is the case of without replacement. Okay, now I have the condition in which that two balls should be taken out. Okay, that is my like if I'm taking out two balls, what is the probability that it like you have to count the number of black balls that I have got. That is my case. Okay, we are taking out number of black balls. Okay, when I'm taking out two balls, what are the number of black balls that I have got? Now, let's do the experiment. So in the first thing, when I'm taking out a ball, okay, one ball, I can have two cases. Either I can have a black ball or a white ball, correct?
Yes, ma'am.
Yeah, exactly,
Yes,
ma'am.
exactly. So what is the probability of getting a black ball?
It's 3/7.
3/7.
3 by 7.
Yeah,
And
3 by
getting a
7,
white ball is 4 by 7, correct?
4
4/7.
by
Now, when I have taken one black ball out, how many balls are remaining?
4 and
6
2.
6 by 6 balls.
6
Four
balls.
white and
2
two
black.
black balls.
2 black.
2
Yeah.
Yeah.
black.
Similarly, in this case, three white ball and three black ball. Correct?
3 by,
Yeah.
yeah, 3 black balls.
Ha. Now, now the second time when I am taking out a ball, I can have two condition: black, white. What is this probability? Two by
2 by
Yeah,
6.
six,
6.
and
4
this
by
will be
6.
four by six.
4 by
Similarly,
4
for
6.
by
this
6.
also two cases. This is black. This is white. This will be 3 by 6 and 3 by 6. Correct?
Yeah, ma'am.
Yeah,
So
ma'am,
in
correct.
this, so in this total, when I'm taking out two balls, two black balls, right?
Yes, ma'am.
Yeah. Yeah, ma'am.
So this is a black ball, black and white. One. Okay. So this is, if my x is the number of black balls, so this is x equals to 1. Correct? When I'm having, sorry, this is x equals to 2. This is my condition when x equals to 1, and this is my condition in my x equals to 0. Correct?
Yes.
See, you got this thing. See, the
Yes.
first thing is this is the one experiment. After one ball, I am taking out another black ball. So in I have two black balls, right? Similarly, when I'm taken one black ball and after in the second term, I have taken white ball, right? So in short, I have x equals to 1. That is only one black ball, correct? Similarly, this case when I'm yes or no under
Ma'am, you were
We're
not
not
audible.
audible.
yes or no?
Ma'am, you
Your
were
voice
not
Ma'am,
was
audible.
breaking in middle the lecture.
Yeah,
My
your
voice
voice
is
was gone. Yeah, so
Were
we
not
were not
Halt was
able to
not
listen
visible
anything.
actually.
what is mm, mm. Now is it fine? Should I repeat it once again?
Yes, ma'am.
Yes, ma'am.
Okay. From the starting, like for this whole experiment.
No, you were describing like x is equals to 2 and x is equals to 1 and x is
Ah,
equals to 0.
Ma'am,
okay.
why this
So,
is?
sorry.
You were explaining the x is equal to 2. Why
Yeah.
the x?
Yeah. X equals 2 in the sense. See, if you see here, my X is the number of black balls, correct? So X is equal to that means I have two black balls. So if you see in this experiment, the like when I'm taking out two balls, so the first I'm having one black ball, and the second also I'm having one black ball. So in total, I'm having two black balls.
Yes, ma'am.
So this is the case when X equals to 2. Similarly, when I'm taking this case, so this is the case when X equals to 1, because in the first trial I'm having one black ball, in the second trial I'm having second like white ball. So that is my X equals to 1. Similarly, if you look in this case, this is the case when X equals to 1, because in the first is white ball and the second I am having black ball. So that is my so these two cases are my for X equals to 1. And if you see this case, this is for the X equals to 2, 0, because I am having no black ball. Yes, now you got this. Now is it clear?
Yeah.
Hello. Yeah,
Yes,
Yeah,
ma'am.
now it's
ma'am.
clear.
That's
So if
very
you
much
see,
clear.
so if you see here in each, so this is my first and this is my second trial, right? So in the first trial, if you see here, so in the second trial, if you see, my this probabilities are dependent on the first trial, right?
Yes,
Or
ma'am.
the outcomes are dependent upon the first thing, and the probabilities in the first and the second are also different.
Eh,
Yeah,
Yeah, ma'am. It was,
है
they
ना?
Yes,
were
ma'am.
different.
It's
It
different.
is different, right? It is a different. You just see this. This is one experiment. If you see here, this is one, right? So if you see in both of these are different. Similarly, if you see this one experiment, sorry, this one experiment. So if you see the probabilities are different, right? So I'm having, so this is a case in which my the experiment are not independent and they are not identical as well. Okay, both are not independent and identical. So in that case comes the hypergeometric distribution. Okay, so
So basically, hypergeometric distribution is opposite of IID.
is opposite of
I
like
IIT.
binomial. Ah.
Yeah.
So there are two, three things that are the like the clue for a hypergeometric thing is the first thing is the population that I have, it should be divided into two parts. So if you see here, I have total seven balls, right, in this example, and that seven balls has been divided into two parts, which is four white balls and three black balls, correct? So it should be
Yes, ma'am.
divided into two parts. The population should be divided into two parts, and the second part is the probabilities should be different in each of the experiment. So if you see here, the probabilities for this case and for this case is different. For probabilities, this case and this case is different, right? So the probabilities should be changing. Okay.
When you have said population will be divided into two parts,
Ah,
won't it be that case? There will be three parts like white.
no, 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 no. Only two parts. Only two
Ma'am,
parts.
N would be not fixed, right?
N. There are
N
no
would be
num.
not fixed.
N would be here. N is different actually. N no, N will be fixed. Yeah, N will be fixed. So let's take an example. So if you see here my N is what? Two only, right? I'm taking out two balls. So that's why I'm
Uh,
having two experiments, right? Two trials.
Yes, ma'am. Two.
Yeah, so n will be there, but the two main thing is the population should be divided into two parts, and it should be without replacement, or you can say the probability should be different in each of the trials. That is the main point, or like the clue to see whether this distribution is a hypergeometric or not. Is this thing clear a little bit?
Yes,
Yes,
ma'am.
later.
Yeah,
Yes.
ma'am.
Anna? Okay.
Yes, ma'am.
Ma'am, is
Okay.
it always
So,
necessary that probabilities will be different here, like without
ah,
replacement?
in without replacement case, the probabilities will like automatically be different, na?
Oh, yeah, yeah, yeah.
Because, huh. So you can say that if it is a case of without replacement, the main clue is if it is without replacement, it's a case of hypergeometric. Okay. So if you just generalize it, okay, we are just generalizing it right now. There are n items, okay, and from that n items, we are selecting small n items without replacement. Okay. Now, in this n item, I have m of one item and n minus m of other type. Okay, because the population is divided into two parts, so this n item is divided into m of one type and n minus m of second type. Fine. Now, if I have to calculate the probability of x equals to I, this can be written as m I n minus m n minus I divided by nc n. Okay, so this is the PMF of a hypergeometric distribution. So if you
Is
see,
small and capital N.
sorry.
What is the difference between capital N and small n?
See, capital N, if you see in, with respect to this example, now here my capital N is what? 7, according to this example. Yes,
Yes,
the
ma'am.
number of the population is 7 balls, right? Now, 7 balls. From this, I'm
Ma'am, right now you were not
Ma'am,
audible.
you're not audible, ma'am. Ma'am, your voice is not audible.
hello. Is it audible
Yes, ma'am.
now?
Now it's audible, ma'am.
Now it's audible. Okay. So, according to this example, my n is 7 and my small n is 2. Yes or no?
Yes, ma'am.
Okay. Now, for this 7 balls has been divided into two parts where my m is number of black balls. How many black balls do I have in this question? 3.
Three.
N minus m will be
3,
4. Correct?
4.
4.
Yeah.
Yeah. So, and what is my x? X is number of black balls. Correct?
Correct.
Yes,
So,
ma'am.
what is the probability that my x is 1? It is basically what? That I'm getting only one black ball. So just put the values here. In place of m, I'm having 3. What is I? 1. What is n? 7 minus m is 3 divided by what is small n? 2 minus 1 divided by 7 C2. Correct?
Yeah, ma'am.
So if you can you solve it and tell me the answer?
Sure, ma'am.
Yeah.
0.57.
It's 0.5.
Ma'am, 12 by 21.
12 by 21 or
4 by 7.
0.57.
4 by 7.
Ma'am, it's a general formula.
Hmm. Yeah, this is a general formula. So the probability that x equals to 1 is 4 by 7. Yes?
Ma'am, one question I
Yes,
have.
ma'am.
Hmm.
Ma'am, in case if it is without, like with replacement, right? Then we have two categories. Can I still say that randomly picking out a black ball would I can consider it as a Bernoulli trial?
Can you come once again? Can you say it once
Let's
again?
say that it is not without replacement, right? We
Ha,
have
ha,
with replacement.
ha.
So all the events become independent, right? In that
Correct,
sense, can
correct.
I say
Ha.
it as a Bernoulli trial?
By, yeah, it will be a binomial. Yes.
Okay.
Yes. Okay. So we got probability of x equals to 1, 4 by 7, right? Or you can say it was 24 by 42, correct? So if you see here, we got, so if you if you see this example for x equals to 1, the probabilities are like 3 by 7 into 4 by 6 plus 4 by 7 into 3 by 6. If you calculate this value, you are getting 24 by 42.
Yes, ma'am.
Yes, everyone?
Yeah, ma'am.
Yes, ma'am.
Yes? Okay.
No, no, ma'am.
Yeah. So this was, see, in this in this question, we just directly put the values in the formula and we got this value, right? So similarly, you can calculate for probability of x equals to 0 and for probability of x equals to 1. You will get the same values, so the same probabilities. Is it clear? Is the formula clear to
Yeah,
everyone?
ma'am.
Yeah,
Yes,
formula
ma'am.
is clear.
Okay. Formula is clear. What is hypergeometric? You understood what is hypergeometric?
Yeah, ma'am.
Yeah,
Okay.
ma'am.
Yeah, ma'am.
Now, see, now, okay. Now, similarly, in this case also, what is my expectation? Expectation, the value of expectation of a hypergeometric distribution. It is n
Expectation
into,
is n. Yeah,
N to
n.
this is the expectation of a hypergeometric distribution. Now, similarly, and variance of x or a hypergeometric distribution.
N into M by N into N minus M by N.
It will be n into m by n into n minus n by n into n minus n upon n minus 1. This is my variance of a hypergeometric distribution. Okay, so
Ma'am,
this is
these
Ma'am,
my
notes.
yeah, this variance thing is, I'm not getting that.
variance. This is just a formula. See, the same thing is. So if you see in the binomial thing, we so let's take p as m by n. Okay, so this expectation is n into p, similarly n into m by n, and variance, what for the variance of this is npq, right? So I can write this as,
Right.
this is my n, p, and q, right? And this is just a factorizing thing. So there is a condition. If my n is like, what is it? If n is less than capital N, okay, then my n minus n upon n minus 1, I can write it as, let's take capital N, capital N common. So this will be 1 upon n minus n divided by 1 minus 1 by n, right? So n will get cancelled. So I got 1 upon n upon 1 minus 1 by n. So if I'm having n, like if I say that my n is very large from small n, so this will be like what? This will be 0.
Yes, ma'am.
Yes,
Yeah,
ma'am.
ma'am.
Yeah. So this whole will be n. Similarly, if my what all things. So yeah, so this will be okay. So this will be 1. So this my variance will be equal to what? The binomial thing?
Hmm.
Yes? Yes or no?
Yeah.
Yeah. So this is just a factor so that the hyper when my n is very large, my becomes very large. That case belongs to a binomial. The variance belongs to binomial. Okay. So this is just a formula. You just have to remember this thing. Okay.
Okay, ma'am.
Okay.
Okay, ma'am.
Let's do one example.
Ma'am, these notes, where can we get?
Which notes?
Ma'am, whatever you are writing, this entire
It
PDF.
is it it will be in the
Uploaded.
calendar.
It will be uploaded in the supplementary content under
Okay,
live
ma'am.
session.
Okay, ma'am. Thank you, ma'am.
Okay, let's do one example. Okay, let's do one question. Activity, question 11.6, question number 5. Okay, so they are saying that we have 52 cards. From that, 8 cards have been drawn without replacement. Okay, now we have to calculate X is the number of spade cards. Okay, now you have to calculate the probability that my X is less than 3. That is, there are less than 3 spade cards. You have to calculate this value. Can you guys calculate this value and let me know?
Yes, ma'am.
Yeah. Are you able to solve it? Are you guys able to solve it?
Ma'am, can we see
Yes,
the
ma'am.
formula?
Sorry?
Can we see once the formula for that probability?
This one.
Yes, this one. Thank you. Okay, done. Thank you.
The question is done.
No, I just copied the formula.
Achha, okay. Okay, let's do this question. Then we will just do one more distribution.
Ma'am, just give me a minute. Just scroll back to the formula.
Okay.
0.689.
0.689.
Ma'am,
Okay. What?
0.68. 0.682.
0.682. Okay. Any other answers? Is it done? Should I solve it?
Ma'am, questions are
Huh.
like this asked because it is so much big values. Factorial, I mean.
Okay. It's very big, right? Okay. Okay. Just tell, let me. Okay. I am solving it. We won't be solving it the whole. Okay. Let's see what the answer I also don't know. Okay. So if you, I just want that you know, like you understood the concept, how to use the formula, how to put the values in the formula. That is the main thing that I want to know. If you're guys able to put the values in the formula. Yes or no?
Yes, yes.
Okay. So the main thing is if you see here, my n is 52. Okay. So and my x is number of spade cards, right? So my what will be my m? M will be the number of cards, spade card, which is 13. Yes or no?
Yes, ma'am.
And the rest of the n minus m, which will be 39. 39 are non-spade cards, correct? So
Yes,
I've
ma'am.
divided my population into two parts. Okay. Now here from the n52 cards, I'm taking out 8 cards. So my n small n is 8. So now probability of x is less than 3 will be equal to what? Probability that x equals to 0 plus probability that x equals to 1 plus probability that x equals to 2, correct? Now probability of x equals to 1 will be what? What this is MCI, right? So M is 13, C, sorry, let's take 0 only. 13C0, N minus M, which is 39. What is it? What's the
39.7.
formula?
N minus I.
It
N
is N
minus
minus
M.
I. So which will be
7.
8 minus 0
8 plus
divided by capital N is 52, small n is 8. Yes. Similarly, probability
Yes,
that x equals to 1 will be 13C1,
13.
39. 8 minus 1 is 7 divided by 52, 8. 52C8. Yes or no?
Yes, ma'am.
Yeah. Okay.
Yeah, ma'am.
Similarly, probability of x equals to 2 also. 13C2, 39 C6 divided by 52C8. Is this question clear?
Yes, ma'am.
Okay. So if you just like normally if you look into this formula, this is basically what? This is the favorable probability, favorable number of outcomes. This is the total number of outcomes, right? So first thing is I'm taking from the 52 cards, I'm taking out 8 cards, right? So this is 52C8. Like from the 52, I'm choosing out 8 cards. That is my total probability. Now, in the numerator part, if you see my x equals to 0, that means I don't have any spade cards. So all of the 8 cards are my non-spade cards. So from these 13 spade cards, I don't have to choose any card, but from 39, I have to choose 8 cards, correct? Similarly, x equals to 1. That means only from the 8 cards, 1 card is spade and the rest of the 7 cards are non-spade. So from 13, I will choose 1 card. From 39, I will choose 7 cards divided by the total outcome. Yes or no? Now
Yes, ma'am.
is
Yes, ma'am.
the probability little bit easier to understand? Now you got the point?
Yes, ma'am.
Yeah.
Yeah, ma'am. Now it's
Similarly,
possible to
so
understand.
x equals to 2. That means from the 8 spade cards, only 2 are the spade and rest of them are non-spade cards. So from 13, I will choose 2 and from 39, I will choose 6. Got the point?
Yeah, ma'am.
Simple, right? We
Yes,
are
ma'am.
just doing the combination thing. That's it.
Ma'am, I have the confusion in taking in taking the binomial thing. I have taken spade m to the value of 3, and the spade card should be 13, and to the n is equal to 13. I have taken the spade card is equal to the value of n. So
No, my bad.
how yeah, so how I got
Okay, the
confused in
main thing is
between these two things.
if you don't even like if you just don't even remember the formula also now. So the you have got the condition, you have got the question that in total I have 52 cards. From that, 8 cards have to be taken without replacement, and x is the number of x is the number of space cards that I got. Right? So what is probability of x equals to 0? That means from that 8 cards that I am drawing out, the no card are my spade cards, right? So that means it I can write this as 13C8 divided by 52C8. Can I write it like this?
Yes, ma'am.
है ना? So what do you mean by that? That means that I from the 39 cards, this is from the 39 cards, I'm choosing out 8 cards divided by because I have to calculate the probability, right? What is probability? The favorable outcome divided by the total number of outcomes. Yes?
Yes, ma'am.
Yeah. Similarly, in this also, that from the 8 cards, 1 card is my spade and rest of them are non-spade cards. So from the 13 cards, I will first choose 1 spade cards, and from the rest of the cards, I will choose 7 non-spade cards. Like in general experiment. I'm just putting the values.
Okay.
Now is it
Okay,
fine?
ma'am. Yeah.
Yes? Sure?
Yes, ma'am.
Yes. Okay. So it's already 9:38, so I have to just so I will jump to the next distribution. Okay. You guys try to do the activity questions. Okay.
Okay.
Yes, ma'am.
Yeah,
So
ma'am.
hypergeometric is little bit clear to everyone.
Yeah, ma'am.
Okay.
Yeah, ma'am.
Now comes the last distribution, which is a Poisson distribution. Okay. What is a Poisson distribution? Anyone? Okay. So this is the probability of number of events occurring in a fixed interval of time. Okay, so this is Poisson distribution is basically that for that probability that the number of events, how many number of events, like the number of events that are occurring in a fixed interval of time. That is my Poisson distribution. That is where my Poisson distribution is used. Okay, and it is represented as X is following a Poisson distribution with parameter lambda, where this lambda is my average value. Okay, this is my average rate. or you can see the mean value. Okay,
This is
so
average number of events per interval.
per interval, correct.
Ma'am, if
Okay,
this is an interval, we are measuring the distribution, right? Then how it is under discrete distribution?
because it is the number of events, right? We are counting it.
Okay.
Yeah, it's the
Because
number
it
of
is
events.
fixed
This
interval
is
of time.
no, this is actually in that particular point of time, how many number of events have occurred.
Okay.
You got the point?
Okay, I understood wrongly. Okay,
Okay.
I got it. Yeah.
Yeah. So this is how I represent an x if x is a random variable which is following a Poisson distribution with lambda as the parameter, where lambda is my average rate per interval, and the PMF is given to be probability is given to be e raised to the power minus lambda, lambda raised to the power x upon factorial x. This is my PMF of a Poisson distribution, where my value of x is 0, 1, 2 to infinite. Is this clear? This is just that. So you just have to remember the condition where it is used, the Poisson distribution. It is just used. It is basically used when we are taking we are taking like calculating the probability of number of events for a in a fixed interval of time. If we are talking about for a particular interval of time, we say that is a Poisson distribution. Is this fine?
Yeah, ma'am.
Yes, ma'am.
Yeah. Let's any example that you can think of. Like you can say the number of vehicles passing through a toll gate in 1 hour, or you can say the number of person entering a shop in 5 minutes, like that. So like in a particular time, I'm calculating the probability of the events, right? What is my event? The number of people that are coming inside the shop. That is my event. So how many number of people? There are two people that are coming inside. There are three people coming inside. There are four people coming in inside. That event, that experiment is Poisson distribution. Now is it fine?
I mean, we have one question, right, wherein there was a rate of decay in a certain interval and a C constant was calculated. Was that something related to this Poisson distribution as well?
We can.
I remember there was one question where they calculated the rate of decay for certain interval. There was a constant C that they calculated. So is that something?
In which
I don't remember the question. I just remember the like which question number I don't remember, but there was one question like that.
okay. I also don't remember it where. Like if you can tell me where, uh,
Even in
particularly where,
lectures,
then
I
I
was
can.
there. Ma'am calculated a constant value C.
Yeah, that is what. So see, I don't remember all of the lectures, right? So if you can tell me which lecture number, then I can just see.
Okay, sure. I'll check.
Yeah, yeah. It's fine. Okay. So this is my PMF. This is the PMF of a Poisson distribution. Similarly, the expectation and the variance. So this is one distribution whose expectation and variance is equal to lambda only. The variance and expectations are same for Poisson distribution. Okay. So this is just a small thing about Poisson distribution. Is the PMF and the expectation clear?
Yes, ma'am.
Okay. Let's solve one question. Um, small.
Where do we use this? What is the condition?
Sorry.
Where we do we use this Poisson distribution?
Poisson distribution is used when you are like a conditions like in which you are counting the number of events. Like you are just like observing the events for a particular number of for a particular time for a particular period of time.
Is the number of events and number of trials are equal or different?
Mm, Number of trials. The sense, okay, like just if I give you an example that the number of people entering in a shop in 5 minutes or in 10 minutes. So the number of people. So in like what is a particular time that I am taking? It's 5 minutes, right? So in that 5 minutes, how many people are entering? That is my event. So the number of people are like it can be one, two, three, four, right? So that is like the events that are occurring in a particular time or in a fixed interval of space or something kind of like that. That is my Poisson distribution.
Ma'am,
Yeah.
can you please tell that why have you written expectation of x equal to variance of x equal to lambda?
This is just a formula. If you solve this now, what is expectation of x? It is summation of x into e raised to the power minus lambda, lambda raised to the power x upon factorial x, right?
Yeah, ma'am.
So if you solve this thing, the x is going from where? X is going from 0 to infinite. So the summation e raised to the power minus lambda. So this will be summation of x equals to 0 to infinite x raised to the power lambda. Lambda is, you can write this as lambda x raised to the power minus 1 upon x into factorial x minus 1, right? So this x will get cancelled. So you will be left out e raised to the power minus lambda, lambda summation of x equals to 0 to infinite lambda raised to the power x minus 1 upon factorial x minus 1, right? And if you remember, summation of x 0 to infinite lambda raised to the power x upon factorial x is basically e raised to the power lambda.
Yes.
Yeah.
Yeah,
So
ma'am.
I can write this as e raised to the power minus lambda into e raised to the power lambda. So this
Yeah,
will
ma'am.
get cancelled. So I will be left out with lambda. So expectation of x is lambda.
Okay, ma'am. Got it.
Okay. Similarly, you can calculate for variance of x, and when you calculate for variance of x also, it will come out to be lambda only. So this is one distribution in which my expectation and variance are like both the values are same.
Ma'am, how we find the difference between Poisson distribution and binomial and also that generative?
Poisson distribution is like okay
No,
in
in a
that
quotient, if we are given a quotient, how can we like identify whether it is a binomial distribution, whether
in
it
this
is
my n
generative?
is not specified, right? My n can be infinite, right?
Yeah.
So in that case, you can take it that case.
Okay. Okay. Okay.
Hmm. So this is all about Poisson distribution, hypergeometric distribution, and binomial. Are the distributions clear to everyone?
Yes,
Yeah,
Yes,
ma'am.
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 Yes. Okay. So mhm. Okay, there is one question. Let's do one question and we will end up the session. So there is one question. I'm just dictating it. Just listen it carefully. On an average, 240 ambulances arrive at a hospital per hour. So they are saying that average is 240 ambulances per hour. Okay. Assuming that the number of ambulances arriving at a hospital follows the Poisson distribution, okay, find the probability that one ambulance will arrive in 30-second time interval. X is the number of ambulance arriving at a hospital. Now you have to find out that X is equal to 1 at 30-second time interval. Or you can say, let's suppose, just take it as 30 minutes. Can you solve this? Have you guys heard the
Yes,
question?
ma'am.
Yeah.
Ma'am, the rate is which one?
Just take it as seconds only. Average rate is 240 per hour. This is my lambda, right?
Yeah, ma'am.
What is my lambda? Lambda is average rate per interval, right? So they are saying my lambda is 240 per hour. X is the number of ambulance. So I have to calculate that I got in 30 seconds, I have got only one ambulance. That one ambulance arrived in that hospital, right? So per 30 seconds. But the average rate that I've got is per 1 hour. So for 1 hour, I have 240, the average rate. So for 30 second, what is my average rate? It will be that I have to calculate, right?
Ma'am, you have to convert first.
First, you have to convert, right? So how will you do that?
360.
Divided by 3600.
Divided by 3. So, okay. So this
Divided
thing
by
I
60
can,
into 60.
yeah, you can do that. So I can say that for 1 hour, if I convert this 240 into like on the basis of second, I can say that okay, so for 1 hour it is 20, 240. So for 30 seconds it will be 360, that it will be uh so this will be 30, 240.
Ma'am, two ambulance would be in 30 seconds.
Huh. So for 1 hour it is 240. For 30 seconds it will be what? 240 divided by 1 by 120. Yes?
Yeah.
Yeah. So
Yes,
now if you calculate this, you will get 2. So my lambda is 2. That is my 2 ambulance per 30 seconds. Correct? So probability that my x equals to 1 will be what? E raised. So, okay. So in general, my formula is probability x equals to I is e raised to the power minus lambda, lambda raised to the power I upon factorial I, right? So I can write this probability of x equals to what will be e raised to the power minus lambda, lambda raised to the power 1 upon factorial 1. Yes?
yes, ma'am.
Yes or no? So now here I have calculated the value of lambda. So my value of lambda will be e raised to the power minus 2, 2 raised to the power 1 upon factorial 1. So this value, if you calculate this, what is the value that you are getting? So this is 0.27. Is the
Ma'am,
question clear?
how,
Hmm?
yeah, the value of I is equals to 1.
In the question, it is saying the question. If you just heard it, we are trying to find out the probability that one ambulance will arrive in 30 seconds. That
This
is my
is
question.
event, huh?
Huh. Is it clear now? Hmm.
The value of I become 1 because it is given that the rate of one ambulance into the 30 seconds.
Correct. Is this question clear?
Yes, ma'am.
Yeah.
Yeah. Okay. So that was all in this week 11. So it was all about the discrete distribution, in which we had three distributions: binomial, hypergeometric, and Poisson. Binomial is basically the IID Bernoulli trials in which my
Ma'am,
n is
value of
fixed.
x was given 1, right?
Ha.
Okay, ma'am.
So binomial is basically that case in which I'm having IID Bernoulli trials where n is my fixed and the PMF of a binomial is NCX p raised to the power x 1 minus p raised to the power n minus x, and expectation is np and variance of x is npq. Okay, now comes the hypergeometric distribution in which it is the case for like when I'm having without replacement case. Okay, so and the PMF is given to be mci n minus m upon c n minus I divided by ncn. Okay, the expectation is also n into m upon n and variance is n into m upon n minus n upon n into n minus n upon n minus 1. Okay, now the next is last is Poisson distribution, which is the probability of the number of events that are occurring in a fixed interval of time. Okay, and it has one parameter which is lambda, which is the average rate per interval. The PMF is given to be this, and this is the distribution in which I'm having the expectation and variance, the value of expectation and variance to be equal to lambda, which is same for both of the values. That's it. So that is the discrete distribution. Is it clear?
Yeah, ma'am.
Yes?
Yes, ma'am.
Yeah. Okay. So that was all in week 11. So you guys go through the lecture once again. Okay. And on Monday, we have a session for week 12, right? Let me just, Hmm. Right? So on Monday, we will be having an open session for week 12. And Tuesday, we will be having a doubt session for both week 11 and week 12. Okay. So just
Thank
go
you,
through the
ma'am.
videos. Yeah. Just go through the videos and the lectures. Try to do the questions. Okay.
Yeah,
Okay,
ma'am.
ma'am.
Okay.
Okay.
Good night, everyone.
Thank you. Good night.
Thank you, everyone.
Good night, ma'am. Thank you,
Good
ma'am.
night,
Yeah.
ma'am. Thank you,
Good
ma'am.
night. Good night.
Ma'am,
Yes.
if we don't remember the derivation, it is okay.
Sorry.
If you don't remember derivation, I mean,
Which derivation?
for formula, for everything, how it is lambda, for hypergeometric distribution formula, how it is derived.
That you have to remember, na?
But if we don't remember, we just remember formula, it is okay.
Formula. Which formula? Like, okay, formula in the sense like what?
This formula of distribution, any distribution.
Huh. Formula like expectation variance, that.
Yes, if we don't remember the derivation, I mean, how can
Haha,
it
derivation is not important. Derivation is not
in
important.
exam not
Formula is
ask na
important. No, no, no.
some question
No, no, no.
like we just remember the formula,
Ha, ha.
use it.
Hmm.
So my question is this. Okay.
Okay. That's it.
Yeah.
Okay then. Bye, everyone. Good night.